The grand unified theory. Solving the universe's biggest puzzle for decades, physicists have pursued one of science's greatest challenges, finding a single theory that explains how the fundamental forces of nature work together. Known as the grand unified theory GUT, this bold idea aims to combine three of the four known fundamental forces: electromagnetism, the weak nuclear force, and the strong nuclear force into one unified framework. If successful, it would bring us closer to understanding the ultimate laws governing the universe, the fundamental forces of nature. To grasp the significance of the grand unified theory, it's essential to understand the four fundamental forces. Electromagnetism governs the behavior of charged particles, light, and electricity. The strong nuclear force holds the nuclei of atoms together, preventing protons and neutrons from flying apart. The weak nuclear force is responsible for radioactive decay and plays a key role in nuclear reactions. Gravity, described by Einstein's general relativity, shapes space, time, and the motion of massive objects. While gravity stands apart, the GUT specifically seeks to unite the other three forces, which already show signs of connection at high energy levels, like those present just after the Big Bang. The birth of the grand unified theory. The seeds of the grand unified theory were planted in the 1970s, when scientists realized that electromagnetism and the weak force could be unified into the electroweak force under certain conditions. This breakthrough hinted that unification was possible. The next logical step was to incorporate the strong nuclear force into the same framework, leading to the search for the grand unified theory. Physicists believe that at extremely high energies far beyond what we can observe today, these forces were once a single, unified force. As the universe cooled after the Big Bang, this force split into the distinct forces we now observe. Much like water freezing into ice, the challenges and progress. Developing a grand unified theory has proven incredibly challenging. One major obstacle is the inability to recreate the required high-energy environments in laboratories. Current particle accelerators, such as the Large Hadron Collider (LHC), can probe deep into the quantum world but fall short of achieving the energy scales needed to test GUT predictions. Mathematical frameworks like quantum field theory provide tools to study these forces, but inconsistencies remain, especially when trying to incorporate gravity into the equation. This has led to broader theories, such as string theory and loop quantum gravity, which attempt to unite all four forces, forming a theory of everything. Why it matters. The grand unified theory would be a monumental leap for science, explaining why the universe behaves as it does at both microscopic and cosmic scales. It could help answer deep questions, such as, what happened during the first moments after the Big Bang?